let's look at natural language processing, or NLP for short. So NLP is the branch of computer science, specifically AI, concerned with giving computers the ability to understand text and spoken words in much the same way as human beings can. So the NLP tools and libraries are found in the Natural Language Toolkit, or NLTK for short. Python programming language provides a wide range of tools and libraries for NLP tasks. NLTK is a set of open source Python modules used to work with human language data for applying statistical natural language processing. To get started, let us set up the NLTK environment. To set up NLTK, some of the prerequisites are have Python 3.0 or better and a Jupyter notebook. So to set up your NLTK environment, open your terminal, instantiate Python, import NLTK, and type the command nltk.download. So after typing the command nltk download, a window will open. An NLT download window will open, and it will give you different options of which packages to download. Select all and download. In my case, I already have NLTK downloaded on my machine, and so I will not proceed with downloading. However, if you do not have NLTK downloaded on your machine, just click the download button and wait. So now that we have NLTK downloaded successfully, we want to test to confirm that it is working in our notebook. So let's launch the Jupyter notebook. I will open a new terminal. And let's launch a new notebook. So to test that NLTK is working and has been imported successfully in our Python library, we are going to run a simple command, import nltk.corpus. From nltk.corpus, we're going to import Okay, so we're going to run this command, and as you can see, we have successfully run this command. So now that we have successfully downloaded NLTK, let's look at some of the NLTK tools for text extraction and pre-processing. So first, we're going to look at tokenization. So tokenization is the process of removing sensitive data and placing unique symbols of identification in its place to return essential information. So it involves breaking text into words or sentences. We have sentence tokenization and word tokenization. Let's look at how it's implemented in Python. So let's start with sentence tokenization. So from NLTK to tokenize, we're going to import send tokenize. So we're going to assign a string of text to text and tokenize that string of text. Okay, so now that we have our string of text, let's call our let's print our tokenized sentence by calling send tokenize on text. So our results show that the different parts of the sentences have been separated or split by sentence. So this is how sentence tokenization is performed. Let's quickly look at word tokenization and see how different it is from sentence tokenization. So we'll import word tokenize from NLTK.tokenize. So we're going to call the print function and word underscore tokenize on the text. So as you can see, in sentence tokenization, the strings were split by sentence. In word tokenization, each string is separated as an individual. So now let's look at n-grams. So in language, the meaning of sentences is dependent on the order of the words. N-gram is a simple language model that assigns probability to sequences of words and sentences. So in technical terms, they can be defined as neighboring sequences of items in a document. Say we have a text. This is an example of n-grams. 1 gram will split the text individually. 2 grams will split the text according to its neighbor. So this and is will be together, is and an will be together, and example will be together. So they'll be split in 2s, and 3 grams splits in 3s. So n-grams is dependent on the number of splits that you want to perform. So n-grams helps retain the context of a word, because when a word is standing alone, it may be lost in translation. Let's look at stop words. So stop words are natural language words which have very little meaning, such as or, at, a, they, and other prepositions. These words take up space in the database and increase the processing time. The NLTK data library or data dictionary has a list of stop words that are stored in over 16 languages. The following command lists the stop words of the English language found in the NLTK.corpus. So let's import NLTK. So from NLTK.corpus, we're going to import stop words and then set the stop word to English. Okay, we forgot to put the K there. So stopwords.words. Okay, so now we can see the list of different stop words that are contained in the NLTK library. So we could simply use the NLTK stop words and remove these stop words from our text if we're performing any text analysis or any natural language processing task. So let's look at another text mining pre-processing technique, which is stemming. So stemming involves reducing the word to the stem or base form by removing suffixes. So some of the stemming algorithms are the Porter stemming, the Lancaster stemming, and the snowball stemmer. So we will use the Porter stemmer to demonstrate stemming in Python. So before we actually move to the implementation, stemming is simply reducing the text to its base form. For example, we could have dancing, danced, and dance. But the best is dance. So stemming removes the ing and the ed and reduces dancing to its best form, which is dance. Another example would be cooking, cooked, cooker. So all these terms have one single base form, which is cook. So stemming simply reduces a text or a string of data to its best form. So now let's look at an example by implementing it in Python. So here, we're going to import Porter stemmer from the NLTK.stem. Let's walk through the implementation of stemming in Python. So from NLTK, we're going to import the Porter stemmer. We are also going to import word tokenize and send tokenize from NLTK.tokenize. So next, we're going to set the stop words to English, and so let's run this before we proceed. Okay, so we missed the words there. Okay, so we see we have imported our stop words. So now let's proceed with assigning our Porter stemmer to PS. I will just copy this there, and there we have it. So now that we have our Porter stemmer assigned, let's have some text that we're going to use to stem. So now we can tokenize our text before we apply stemming. So we have no errors up to this point. And now let's apply our stemming. So for W in words, let's print our PS dot stem on W. Okay, so there we go. So our text has been reduced to its best form. So we have cook, we have cooking, which is now cook. If we look at evening, it's now even. But this shouldn't be the case. It should say evening. So you have to be careful when applying stemming and ensure that the text has been reduced to its true base form. Okay, so now that we've looked at stemming, let's look at another data preprocessing technique, lemmatization. So lemmatization is the process of grouping together the different inflected forms of a word so they can be analyzed as a single item. Let's look at the implementation in Python to understand what lemmatization is. So from NLTK.stem, we're going to import the WordNet lemmatizer. The next, we're going to assign the lemmatizer to our WordNet lemmatizer. So we have no errors up to this point. And so let's print out our drinks string and apply lemmatizer to the drinks. Okay, so next, we're going to apply lemmatizer to another string. So let's say we want to apply it to corpus. Let's apply it to another string. I'll find a string and just see how lemmatizer actually works. So we could say sunsets. So we have sunsets coming out of sunsets. We could also maybe adjust this and say computers. The computers come out as computers. So as you can see, drinks has been lemmatized to drink. Corpora has been left as corpora. So this is the respective implementation of lemmatization in Python. So next, we're going to look at part-of-speech tagging. So part-of-speech tagging marks words in a corpus to a corresponding part of a speech tag based on its context and definition. So pose tags are useful in building name entity recognition, in lemmatization, and extracting relationships between words. Let's look at the implementation of pose tagging in Python. From NLTK, we're going to import the default tagger. So next, we're going to define our tag. So let's move to tagging. So now that we've defined our default tagger, NN, we're going to move to tagging. So as you can see, we have tagged our list of words. So each list that we have has been tagged NN. Now that we have looked at the different text mining pre-processing techniques in NLTK, let's look at one final technique, the name entity recognition. So name entity recognition seeks to extract the real-world entity from the text and sorts it into predefined categories such as people, locations, organizations, dates, etc. NRE output for the sample text would typically be, so for person, it would tag Pendo Manjali, Larry Nor, let's say Maria Parker, and we have Joan. So any ARA will get these names and tag them to person. If it identifies a location, it would tag it as location and extract that information. For example, Lusaka, Kigali, Lagos. For organization, let's say there's AT&T in a string of text. Any ARA will extract that and tag it to organization. So any ARA is generally based on grammar, rules, and supervised models. So let's look at the implementation of name entity recognition in Python. So we'll import NLTK and we have a body of text. So our body of text contains names of people, location, date, etc. But before we proceed with our name entity recognition, we have to apply tokenization to this text. So in this case, we're just going to tokenize the words. Then we're going to tag our sentence using the pose tags. Next, we're going to apply chunking to our tagged sentences. And finally, we're going to create an empty list. Let's call it NE. So for tagged tree, in the NER chunked sentence here, the sentences that have been chunked, we're going to apply our name entity recognition and have the entity name and the entity type as a key value pair. So printing the output, so we have an error here which is saying name entity is not defined. Okay, so we're getting this error because we assigned our empty list NE. Okay, so now that our error has been cleared, as we can see, we have our name entities tagged. So Mark Potts / Washington Post is tagged as a person. So all the text that is marked as person has been tagged. And we have our location information as well tagged here. So named entity recognition helps with tagging and identifying entities within bodies of text. So now that we have an understanding of the NLTK tools, let's dive into NLP first by understanding the NLP process workflow. So first, we apply tokenization to text, that is replacing sensitive data with unique symbols of identification to retain essential information. Then, we remove the stop words. So removing stop words includes removing common words that don't add much meaning to the data, e.g. prepositions, punctuation, etc. So after removing the stop words, we can apply our stemming and lemmatization. So these reduce the words to the best form. Then we can apply post tagging. So post tagging tags words to be part of the speech based on the definition or context. Then finally, we have information retrieval, which is extracting of relevant information such as keywords from the source, and this is the information that we can use for building or training our algorithms.